7.4 is writing equations in two variables. Our first term is equation in two variables. So it means basically it's representing two quantities that change in relationship to one another. Alright, another kind of a term, I guess, but a solution of an equation in two variables is an ordered pair that makes the equation true. So I'm going to give you some examples here of what this makes, or how this makes sense using the x and the y-axis. We're kind of back to that because we're going to be talking about ordered pairs, right? So pay attention and make sure you're writing everything down. Example 1 is identifying solutions of equations in two variables. So your directions would read like this. Tell whether the ordered pair is a solution of the equation. So you would be given an equation like this, y equals 2 times x. Then they give you an ordered pair. What you need to do is plug in what your ordered pair is and see if it's a solution. So watch how I do this. So we start with y, right here. We have to figure out which one is y, which one is x. If you remember, and I've told you this so many times, that the 3 would be our x value and the y would be the 6 would be our y value. There's x, y. You have to remember that this is what it would look like in an ordered pair. No matter what, x will always come first and y will always be second. So now we just need to plug in. So I'm going to plug in my y value at 6 because that's what it is. So now it becomes 6 equals 2, and then my y value, or my x value, which happens to be 3 times 3. So what I've done here is I plugged in my y value of 6 from here, and I plugged in my x value of 3 from right here. This told me what those two numbers happen to be. Now I can solve. So to solve that out, I'm going to leave my 6 because there's nothing to do over there. 2 times 3 happens to be 6. So is y equals 2x with our ordered pair of 3, 6, is it a solution? My answer would be yes, because 6 does equal 6. Okay, now I'm given this. My equation is y equals 4x minus 3, and my ordered pair is 4, 12. Remember, this is my x, this is my y. So now all I'm doing is plugging in. So my y value is 12, so I plugged in my 12. I leave 4 because there's nothing I'm doing there. My x value happens to be 4. And there's nothing I'm doing to the minus 3. That was something set up for me. So now I can solve. Order of operations tells me to leave my 12 equals. Order of operations tells me to do multiplication or division first. 4 times 4 happens to be 16. And now I have to subtract my 3 from it. So my next step down, 12 equals 16 minus 3 is 13. Well, we should recognize that 12 does not equal 13. So my answer is no. It is not a solution. 4, 12 as an ordered pair is not a solution for y equals 4x minus 3. Okay, so quite a bit of notes to take real quick. I just want to talk you through these, and you can either pause right now and write them all down, and then we can go through them, or you can write as you go. So it says you can use equations in two variables to represent situations involving two related quantities. The variable representing the quantity that can change freely, this is important, it's called the independent variable. So if you think about it, like I always told my students before, independent means you can kind of come and go as you please. You're independent. You have power to do those things. So kind of when you go to college and you can eat when you want to eat. You can do those things. You're independent. So that means it changes freely. The other variable is called the dependent variable. This means you're dependent on somebody. So the difference between independent and dependent is, so right now living with your families, you rely on them to help make, or to make dinner, or you don't have a choice when you eat most of the time and stuff like that. So it's dependent variable because its value depends on the actual independent variable. Once we put these into some numbers and some examples, it'll make a little bit more sense, but you might have to refer back to this page again so that you understand the difference between independent and dependent. Alright, example 2 is using an equation in two variables. The equation y equals 128 minus 8x gives the amount y in fluid ounces of milk remaining in a gallon jug after you pour x cups. The first thing that we need to do is identify the independent and dependent variables. Okay, so I just rewrote the equation that they gave us. Because the amount y remaining depends on the number x of cups you pour, y happens to be the dependent variable. So that means that x is your independent variable. The reason that works out is because basically what we're saying is that x can be any number. Let's say x was 2. If x is 2, then y becomes something else as well. We can't just plug in any number for y right now because we're talking about x being the number of cups. So that means it's independent. It can be flexible. We could have 2 cups, we could have 10 cups, we could have 15 cups, we could have 2.5 cups. But this variable right here has to be, it can be anything. So that makes the y variable dependent on the x variable. That's why this is the dependent variable and this is the independent variable. It's kind of hard to understand, but once you get through a few of them, it makes more sense. And the second part of the question says, how much milk remains in the jug after you pour 10 cups? Well, we have to recognize that x is representing our cups, because that's what it said in our original problem. And we also know that it gives the amount y in fluid ounces of milk remaining. Well, we don't know what's exactly remaining because that's our dependent variable. So what we have to do is we have to substitute our x for 10. We have to put in 10 and see what happens. So we start with y equals 128 minus 8x. Okay, now we're just simply going to fill in that stuff with 10. Y equals 128 minus 8. And we're putting in the number 10. Okay, so now we can start solving. Order of operations tells us to solve 8 times 10 first. We should come up with 80. Then I'm just rewriting what I have here. And now we can solve because we can subtract 128 minus 80. So y ends up equaling 48. But what does the 48 mean? It means that there are 48 fluid ounces remaining. And that would be your answer. Alright, here are some try-it problems. These are right from your book on page 316. It says, on your own, tell whether the ordered pair is a solution of the equation. That would be from numbers 1 and 2 are from example 1. And then example 2 is number 3. So they give you the equation just like we just got done working with. They're telling you what each of them are representing. We're identifying the independent and the dependent variables. And then it gives you the number of weeks that they're talking about. So plug all that in, get your answers, take your time and do them, and your answers will be on the next page. And here are the answers for 1 through 3. Number 1 was not a solution. Number 2 was a solution, or yes. And then number 3, or independent variable, was the x, and the dependent was the y. And then part B was $105. And you're done.